The math behind function operations we've actually already done. We're just going to incorporate function notation. So the wording or the question itself might appear different, but again, the math we have done before. Here we're given two functions. They're just polynomials, but they've been identified as functions and given names. We're asked first, in number one, to add the functions, f of x plus g of x. This notation also means to add the functions, f plus g of x. So if you see that notation, it's the same. And that literally means we take the f of x function, 2x, and we add it to the g of x function, 8x minus 6. Parentheses weren't really, didn't have much of an impact there, and we combine like terms. We've created a new function called f plus g of x. And that is still a polynomial, so the domain of that function would naturally be all real numbers. In number two, we're asked to subtract the functions. This would be a different notation for the same subtraction operation. And when we subtract, we need to be careful about subtracting the second polynomial because we have to subtract both terms or distribute the subtraction, and that becomes a plus 6. Now when we combine like terms, we end up with a new function, subtraction function, which is still a polynomial, so the domain is all real numbers. Working with the same two functions, let's find the multiplication function, which could have been represented by this notation, f g of x. That means multiply the functions. And when we are multiplying polynomials, we are required to distribute. And that resulted in a quadratic polynomial, but it's still a polynomial, so the domain is all real numbers. When we divide, the other notation would look like f divided by g of x. And when we divide, we create a fraction. And actually that fraction can be simplified. If you notice, all of the numeric values are even. So think of the numerator as 2 times x, and think of the denominator as 2 times 4x minus 3. So I factored a GCX, and then the fraction can be simplified. Let's talk domain, however, because you should recall that we mathematically cannot divide by 0. And now that we have a fraction, we have a division operation, we have to make sure that 4x minus 3 does not equal 0. So solve this non-equation or unequation just like you would solve an equation. Add 3, divide by 4, and it tells us that the domain is no longer all real numbers. We have a domain restriction. The excluded value of the domain is 3/4. So that's like a hole in the graph. We would write the domain just like we would write the domain when there was a hole on a number line. All real numbers except 3/4. Just some repetitive answers. We have questions. We have 2 new functions here. We have a quadratic function and a linear function. F of x is quadratic, g of x is linear. number 5 asks us to subtract those. X squared minus 2x minus 15 minus x minus 3. Make sure you have not forgotten about that subtraction being distributed. And combine like terms. The result is a polynomial function, so the domain is all real numbers. Next, we multiply the two functions. And since multiplication is commutative, I'm going to put the binomial at the front. That doesn't have to be done, it's just my preference. I'll distribute the x, and I'll distribute the 3. And then I'll combine like terms. Our result is still a polynomial, it's a cubic polynomial, but since it is a polynomial function, the domain remains all real numbers. There's no domain restriction with polynomials. And then finally, f of x divided by g of x. Looking at the denominator, we have to realize that we cannot mathematically divide by 0. So the denominator cannot equal 0, which means x cannot equal negative 3. My domain of this new function would be all real numbers except negative 3. And this function could also be simplified, but the domain refers to the very original function and the fact that originally we were dividing by x plus 3. Then we could simplify by factoring the numerator. And simplifying the common factors. However, the original function involved division, so even the simplified function still has a restriction to its domain.